Welcome to Kumvitech. Today we're comparing the scale of minus one of the world's most destructive nuclear bombs, including one so devastating it was deemed too risky to use. Brace yourself, it's about to get loud. Starting off, we have the 15-kiloton bomb that the US dropped on Hiroshima in 1945. Little boy caused the deaths of around 80,000 people and exposed tens of thousands more to high levels of radiation. It gets worse. The temperature near the blast site in Hiroshima reached 300,000 degrees Celsius. For perspective, that's about 300 times hotter than the temperature bodies are cremated at. Sounds horrifying, right? Well, we're just getting started. In 2017, North Korea detonated a nuclear bomb 16 times more powerful than the one that devastated Hiroshima. The nuke is said to have weighed in around 250 kilotons-ish. Yeah, here's where things get a little murky. Researchers aren't exactly sure what the bomb was, and North Korea isn't spilling the tea, but they estimate it was between 148 to 328 kilotons. On the other hand, the US intel community estimated it was 140 kilotons. One thing is for sure though, it was felt all around the world. Seriously, this bomb was so intense, caused an earthquake with a magnitude of about 6.3. The sound waves from the explosion wwere so powerful, picked up by seismometers worldwide. Up next is one of the most powerful bombs in the arsenal, the B-83. This nuke has a yield of around 1 megatons of TNT. But what does that mean exactly? Well, let's break it down. You don't need to be a nuclear physicist to know. You want to be far away from one of these. Once it hits, it'll create blast waves with a force of about 180 metric tons and wind speeds of 255 kilometers an hour within a 6-kilometer radius. If you were within about a 21-kilometer radius, you'd experience flash blindness. Within an 8-kilometer circle, you'd get third-degree burns. You know where your body tissue gets and then destroyed. And if you're within a 1-kilometer radius, you'll be hit by blast waves with 720 metric tons and winds of 756 kilometers an hour. Medically speaking, it's gonna suck. There are about 650 B-83s in active service. So that's comforting. Next up, Castle Bravo. The biggest nuclear bomb ever tested by the US. Packed a punch of around 15 megatons and caused an explosion 2.5 times devastating than researchers anticipated. And this was obviously a problem. Yeah, this bomb was 1,000 times more powerful than the one dropped on Hiroshima. Radioactive debris spread across 18,000 square kilometers, contaminating people on nearby islands and even on a Japanese fishing trawler. This was dubbed the worst radiological disaster in US history, and it caused a massive uproar against nuclear testing. Understandable when you see the staggering 7-kilometer wide, 39.6-kilometer high mushroom cloud. Oh, and it created a crater on the ocean nearly 2,000 meters wide and 76 meters deep. That's huge. But the next two on our list are even bigger. The Tsar Bomba 50 was not your average bomb. It was a hydrogen bomb, and the most powerful one ever tested. It had a yield of about 50 megatons. In 1961, the USSR detonated it on a small Arctic island, creating a shockwave that turned the island into a flat skating rink. The bomb was commissioned by Nikita Khrushchev and weighed 27 tons and required an arrow to transport it to the Arctic. The detonation was so powerful that it knocked the bomber down 900 meters before the pilot could course correct. It's not hard to see why a bomb with this kind of power was never made again. But that doesn't mean the USSR didn't want to okay. So Khrushchev may have commissioned the Tsar Bomba 50. But did you know he originally wanted a 100 megaton nuclear bomb? Yeah, plus 50 baby. The plan was to create a 3-layered bomb, with uranium layers separating each stage. But testing the bomb was too, what's the word, risky? Even Soviet physicists were worried the bomb would cover the whole North, the USSR, with a massive cloud of radioactive fallout. And if that wasn't enough, the bomb was too heavy. So heavy it couldn't be placed on a missile or strapped to any plane. And even if it could have it would have taken a crazy amount of fuel to get to the target and fly away safely, making it a one-way trip for any pilot. How long do you have to wait inside from nuclear fallout? Find out here on How to Survive.